So in this section, we're finally looking at chemical reactions, and we're going to see what information we can get from the way a chemical reaction is written. So here I've got my reaction, and it tells me CH4 is reacting with O2. Everything on left of the arrow, remember, is always called a reactant. The arrow signifies that it's changing, and it's forming CO2 and H2O. The stuff that's on the right of the arrow, the stuff that forms, are my products. The symbols in the parentheses represent the state: S for solid, L for liquid, G for gas, and AQ for aqueous or dissolved in water. Okay? So I can already tell some information. Now it's also important that I remember atoms are not created or destroyed. Going back to the law of conservation of mass, the law of conservation of matter, all I'm doing is rearranging partners. So if I start with 3 carbon atoms, then I have to end with 3 carbon atoms. If I start with 6 oxygen, I need to end with 6 oxygen. I can't mess up my count, okay? So here I've got my reaction again, and it's showing me some information. So I know what my reactants are, CH4 and O2. I know what my products are, CO2 and H2O. It also tells me, because there's no number in front of CH4, that I need 1 molecule of CH4 for every 2 molecules of O2. Now, because I can't actually count out molecules, instead of keeping track of molecules, I could have 1 mole of CH4 or reacting with 2 moles of O2. That's the same thing as saying 6.02 times 10 to the 23rd molecules. 1 mole is equal to Avogadro's number, plus 2 moles, or 2 times Avogadro's number. Now I know that 1 mole is equal to the molar mass, the number from the periodic table. So the 16 grams came from the formula for CH4. 12 grams for carbon, 1 gram for each hydrogen, and there are 4 of them. 12 plus 4 is 16. The 32 grams comes from the fact that oxygen weighs 16, and there are 2 of them. So 32 grams is the molar mass of O2, and because I have 2 of them, I would need 2 times the molar mass of O2. Because it's 16 plus 64, I'm going to need a total of 80 grams of both of my reactants to make this go. So just by looking at my reaction, just by writing out this information, I already know a ton about my reaction, okay? Now, because matter can't be created or destroyed, the atoms of a compound cannot be created or destroyed. And when I balance a reaction, I have to keep track of those atoms. Now, as I balance my reaction, it's important to remember that I can't actually change out what's reacting or what's forming. I can only change out numbers. So again, I had this reaction here. CH4 is methane. I couldn't make it C3H8, even if that would make it balance better, because that would be a completely different compound. I couldn't make this O3 because then it wouldn't be oxygen anymore, it would be ozone. So I can't mess with the little numbers, okay? I can only change amounts of my compounds, okay? So here we've got some examples. Now the easiest way to balance a chemical reaction is to compare what's happening on the left of the equation to what's happening on the right of the equation. Here, I've got carbon, I've got hydrogen, and I've got oxygen. I have to have the same atoms on both sides. Even though they're not in the same order, I'm going to put them in the same order so that it's easier for me to see whether they're balanced or not. On the left side of the equation, I've got 2 carbons. On the right side of the equation, I only have 1. Well, I know I'm going to have to do something to fix that because right now I'm creating or destroying matter. That's not allowed. Okay? So, on the left side of the equation, I've got 5 hydrogens here, 1 hydrogen there, for a total of 6 hydrogens. Here, I've only got 2. Again, I'm destroying matter. On the left side of the equation, I've got 1 oxygen here, 2 oxygens here, for a total of 3 oxygens. On this side of the equation, 2 oxygens here, 1 oxygen there, for a total of 3. Anytime they're separated by a plus sign, we add them together. Okay? Now, when I balance things, I probably wouldn't want to start with oxygens because they're in more than one place. So I'm going to start balancing things that only appear once first, and then I'll worry about my oxygens at the end. Hopefully everything gets cleaned up before then. So I'm starting with 2 carbons. I need 2 carbons over here. So I'm going to put the 2 in front of where my carbon is. By putting the 2 in front, we call this a coefficient. I'm multiplying this entire thing by 2. So now, I originally had 1C, 2 times 1. I've got 2. I originally had 2 O's here. 2 times 2 is 4. But I still have this 1 O over here. So I have to keep track of that. My C's are okay now, so I'm going to move on. I've got 6 H's here, 2 H's here. Well, I need to change this one. 2 times 3 equals 6. Well, that doesn't just change the H's, okay? It's going to change the O's as well. Over here, I've got 3 times 1 is 3. I've got 2 times 2 is 4. So now I've got 4 O's here, 3 O's here, for a total of 7 O's on this side. Well, unfortunately, I didn't fix my O's. I fixed everything else. So now I need to look at this side of the equation. I don't want to mess with this compound. And the reason I don't want to mess with this compound is I'll screw up my C's, I'll screw up my H's, which are already fixed. I just want to mess with these O's here and hopefully make it work. So, since I'm not working with this compound, I already have 1 O that I'm leaving alone. I want to get to 7 O's. So I need 1 plus 6 to get to 7. So I need to turn this O into a 6. Well, we already said that by multiplying 3 times 2, I get 6. And now I've balanced my equation. Okay? So same thing down here. In this case, I've only got 1 reactant, but I've got 3 products. So I want to make sure that I separate it at the arrow. Reactants on the left, products on the right. In this case, I've got N, I've got H, Cr, and O. Now, NH4 is a polyatomic ion, ammonium. Cr2O7 is also a polyatomic ion. If these looked exactly the same on the left of the arrow and the right, I can leave polyatomic ions together. But because they no longer look the same, NH4, N2, I have to break them up, okay? So on the left of the arrow, I've got 1N in parentheses times 2, so 2 N's. On the right side, I also have 2 N's. On the left side, I've got 4 H's in parentheses, 2 on the outside, 4 times 2 is 8. On the right side, I've only got 2. On the left side, 2 CRs. On the right side, 2 CRs. On the left side, 7 O's. On the right side, 3 O's here, 1 O there, 4 O's total. Okay? So let's see what I want to fix first. My N's are already okay, so I'll leave those alone. My H's aren't. 8 here, 2 here, so I need to multiply my H by 4. 2 times 4 equals 8. 2 CRs, 2 CRs. I don't need to do anything to that. Well, right now my O's don't match, but the reason they don't match is because I screwed up. By putting the 4 here, I changed my H, but I didn't just change my H. I also changed my O. Not this O over here. I still have 3 O's here, but over here I now have originally 1 multiplied by 4. 4 times 1 is 4. 3 oxygens here plus 4 oxygens here equals 7 oxygens, and now it's balanced. Take a second and solve example 12. Come up with all of your coefficients for your balanced reaction.